Okay. If you didn't hear me say it, I apologize. I'm starting to lose my voice. Woke up this morning, had some phlegm in my throat, and that's never a good sign for me. It means my phlegm, like stuff you cough up, and it's like snot, basically, discolored snot. So sorry about that, Madison. Anyways, yeah, so it doesn't usually bode well for me. It means I usually lose my voice by the end of the day. I kind of know how that goes. So hopefully I'm back at it tomorrow. Feel fine, just not able to talk. So I'm going to be kind of soft spoken. Fortunately, we don't have that much to do today other than go over this test, finish the few problems we have left in our notes, and then I can help you as much as I need to, because the rest of the period will be a work day for you guys to finish up your packets, which are due tomorrow. So out of 62 points. Okay, points don't matter. Your percentage matters. Whatever the percent is on top of your test is what's in Skyward. Okay, test, of course, being worth 45% of your grade. Some of your grades might have taken a little bit of a hit with your test grade, so that's where the retake comes into play. If you're interested, I will average your scores together as long as you improved your score. I'm not going to make it any worse than what it is, and then that can bring your score up a little bit. Okay, so if you went from, for example, got an 80%. Retake it, get a 90%, it's going to go in as an 85. Got a 60%, retook it, got a 90%, it's an increase of 30, average that together, you add 15 to that, it's going to go as a 75%, much better than a 60%. Okay, so retakes there if you want it. Number one on the test, the quest is a test. The square of an integer is always positive. Whenever you square a number, whether it's negative or positive, it's always going to be a positive answer. Number two, a decimal that does not terminate is sometimes irrational. An example of or maybe I should say a counter example of when you would see a decimal that doesn't terminate that is rational is, for example, 0.3 repeating. That decimal will never stop. It'll go on forever, but we know that to be 1/3. And if you can write it as a fraction, then of course it would be rational. Okay, any repeating decimal is going to be rational. Now, if it goes on forever and doesn't repeat anywhere along the way, then we know it's going to be irrational, like 5. Number three, a Pythagorean triple is always a set of 3 natural numbers. Natural numbers, remember, start at 1, 2, 3, 4, 5, 6. You can't have a side of a triangle with 0, so they can't be whole numbers. They're not going to be negative because you also can't have a side of a triangle be negative. They'll always be positive answers. No decimals or fractions are allowed in Pythagorean triples, so natural numbers only. Number 4, 25. Number 5, positive and negative 14. You had to write both. And number 6, negative 19. It is okay to have a negative sign outside a square symbol. That means they're asking for the positive version. If there's no negative sign outside, that means they're asking for the positive version. So negative version, positive version, asking for both here in the middle. Number 7. Order of operations says exponents have to be dealt with first. That's where your square root comes in. The square root of 1/16 is 1/4. What you do is you square root the top number and you square root the bottom number. Just like in our exponents chapter right now, if I asked you to take 1/3 squared, you would square the top number and bottom number to get 1/9. Or you could literally think 1/3 times 1/3 is 1/9. Okay, so when you square root a fraction, you square root top and bottom. So that's where the 1/4 comes in. What's the next step in order of operations after exponents? Please excuse.
Multiplication or division, right?
Yep, multiply and divide from left to right. We only have one multiplication problem. It's right here. 4 times 1/4. 1/4 of 4 is just 1. And then I can do the adding and subtracting step at the very end. 10 minus 1 is 9. Some of you still need to learn your order of operations. You cannot subtract 10 and 4. You can't do it. That's out of order. Okay, you have to multiply before you subtract. Number 8, 54 and 6, neither one of them are perfect squares. But what's 54 divided by 6? It's 9. 9 is a perfect square. So you can simplify 54 over 6 to 9. The square root of 9 is 3. You're adding 2/3 to that. I'm waiting to the very end to add 2/3 because adding and subtracting is always the last step you do in order of operations. For those of you that tried to make that an improper fraction, you didn't have to. You could just add 2/3 to 3 and call it 3 2/3. Okay. If you did write it as an improper, it would have been 11/3. Okay, 11/3 I would have accepted. Number 9. What does a square root do? Why do they call it a square root? Well, it finds the root of your square. It finds one side of your square. So if I have the area of my square, the square root is going to tell me what two numbers I multiply. Now, when I say two numbers, it's actually the same number. So what number do I multiply by itself to get that 1.69? And so the square root of 1.69 is 1.3. We have to label, as a story problem, it said label 1.3 kilometers times 1.3 kilometers gives me an area of 1.69 square kilometers. AJ.
So, what square root is 1.69?
Yes. You wouldn't have lost a point. Yep. Number 10. This one, you at least had to put square root 1 is 1. Now, most of you did something like this. You said the area formula for a square is pi r squared. You plugged in the area that they gave you down here at pi. So pi equals pi r squared. And that's where some of you got lost. Both sides have a pi. When you scratch out the pi on both sides, it does not leave you a 0 on that side. Pi divided by pi is 1. Any number divided by itself is 1. So this should be 1 equals r squared, and then we can square root to get 1. So 1 yard. Caleb.
I put r equals 1 and you took off 1.5 points.
Come show me.
It was just at the top of my board.
May not have seen it. Come show it. Come show it to me. What were you
I
saying?
didn't,
Cooper?
if I didn't label.
I didn't label, but I had articles.
Yep, I'll give you 1 point back. I'm gonna take that half point, obviously, for the not labeling. Bring it up to me when we're done, okay? And I'll change it after we're done, because I'll forget.
I was saying I was gonna come back to that problem. I always do that and then I forget to come back to it.
I think I just followed the trail of your work. I thought it would be at the bottom there. Now, 11 through 16, you had to select each name that you could possibly apply to these numbers. Number 11, this is a decimal. It terminates. So that means it can be written as a fraction. This would be -1 and 125 thousandths before you reduce it down. It's actually -1 and 1/8. So because you can write it as a fraction, it's rational. Number 12, 15 is not a perfect square. Now you can try typing square root 15 into your calculator, and that's fine if you do that. But knowing that 15 is not a perfect square means you're going to get an irrational number. That's why we call them perfect squares. Okay, so square root 15, I don't know what it is. Something just smaller than 4, 3.9, 3.8 something. But it's going to be irrational because it's going to go on forever. It's got no repetition to it. And so that's irrational. Number 13, what's wrong with number 13?
Oh, you can't have a negative number inside a square root.
Yes, can't have it inside the square root. There isn't a number that when you square it gives you -64, only +64. So that one's not real.
Or
Go
it
ahead.
should have been in the cube. Then it would have been fine.
If it was a cube root, it would have been fine because the cube root of -64 is -4 and you would have just marked integer. But since we didn't go over cube roots, I had to take that problem off and leave just this one up. So number 14 on the second page, 576 is a perfect square. That means you're going to get a nice answer, which means your answer is going to be not only rational, but it's going to be an integer. It's going to be a whole number and it's going to be natural. There's no way that you can select natural number here and not select these other three because all natural numbers are whole numbers. All whole numbers are integers and all integers are rational.
Did you copy that sign up?
No.
Oh.
Number 15, because it has a pi, it's irrational. Pi is irrational, times it by 4, it's still irrational. Okay, if you're thinking about 3.14, you're thinking about a decimal we've rounded pi to. Pi itself is irrational. Number 16, that is a repeating decimal. Yes, it goes on forever. This is your example of a non-terminating decimal that can be written as a fraction. 25 over 99 can be written as a fraction, so it's rational. Number 17 and 18, both kind of pair up together in the same problem here. 17, you're choosing a possible value for A, and for 18, you're choosing a possible value for B. Now, I know it has to be bigger than 81, because if I square root 81, I'm going to get 9. And if I square root 100, I'm going to get 10. And A is just bigger than that. So I can rule out this one, and I can rule out this one. The only two that even work for this problem are these two right here. Because the square root of 100 is 10, square root of something larger than that's going to be more than 10. Square root of 81 is 9, square root of something smaller than that's going to be less than 9. So these are the only two that work. Now, how do I know which one's which? Well, that one's smaller than this one. That's it. So this has to be square root of 85. And that has to be square root of 96. Yes, do you have a question? Number 19 and 20, we just talked about this. If I have a repeating decimal, I definitely can write it as a fraction. If just the 10th digit is repeating, put it over 9. So this is -1 and 2/9. If both the 10ths and the 100th digit are repeating, put it over 99. 27 over 99, however, can be reduced by 9 to 3 over 11. If you reduced it by 3 to get 9 over 11, sorry, if you reduced it by 3 to get 9 over 33, then it would reduce down farther to 3/11. What if the 10ths, 100ths, and 1000th digit are all repeating? What do I put my number over? Levi? 999. You got it. Yep. Number 21 and 22, Pythagorean theorem problems. And number 21, x is your hypotenuse. So that needs to go where the c would normally go in the a squared plus b squared equals c squared formula. 4 squared is 16, 6 squared is 36. That's going to give me 52. And the square root of 52, it's not a perfect square. So I'm either going to leave it like that because it says simplify, or I'm going to try to simplify it by taking out a perfect square. And there is a perfect square that goes into 52. It's 4. 4 goes into 52 13 times. The square root of 4 is 2, so I can simplify this down to 2 square root 13. Number 22, x is no longer the hypotenuse. This time x is one of your legs. So 7 squared plus x squared equals 9 squared. 9 is your hypotenuse. 49 plus x squared equals 81. Subtract 49, you get 32. There is a perfect square that goes into 32. It's 16. Now that's the largest one. If you pull out a 16, square root of 16 is 4. You get 4 square root of 2. Some of you pulled out a 4. Now, I got no problems with that, but you're not done. If you pull out a 4, square root 4 times square root 8 gives you square root 32. So some of you got 2 square root 8 as your answer. However, that 4 that you pulled out goes in again. You can pull that 4 out of that 8. And then now you have 2 times 2 times square root 2 or 4 square root 2 like everybody else got. Okay, that's like saying I'm going to reduce 12 over 24 to 6/12. Keep going. 3/6. No, keep going. 1/2, right? Pull out the biggest number you can, and you'll have to reduce less. Third page, last page. The reason you may have missed number 23 is because maybe you didn't label it in meters, or more likely, you thought of the ladder as being the wall. The ladder in this instance is our hypotenuse. So here's my wall. The ladder is leaning up against the base of the wall, and it's 7 meters from the base of the wall. So if I draw a picture, that might help. There's my wall. There's 7, there's 25. It wants to know how far up the wall will the ladder reach. That's my A value here, my leg. So that's going to give me 49 and 625. Subtract 49 over. We already said 576 is a perfect square. Okay, it's 24. So 24 meters. For those of you that got 26 meters, you rounded it correctly, but you put it in the wrong spot. 25 squares should not be a leg. It should be the hypotenuse of the triangle. Number 24 was worth 4 points, not because you had to draw a picture, you already had a picture, but because when you got your answer, it asked what the total height of the tree was. So you had to add 8 feet onto what it was, because when you got 12.8, that gave you how tall the tree that was axed off was or cut off. So before it was cut, it would have been that plus 8 more feet to be 20.8 feet tall. Yes.
How did they get 8 feet up to chop it down? And why? Why would you cut it down 8 feet above the
I got a pole saw.
Christmas tree?
8 feet's not that tall. I mean, 8 feet's like right there. So maybe they were on a stool. Why they chose 8 feet? I don't know, because 8 and 10 are nice numbers, but not a Pythagorean triple, obviously. Otherwise, you would have got a non-decimal number there. Number 25, the two short sides of your legs, 36 squared and 77 squared, give you 1,296, 5,929. That's 7,225. It's exactly what you get when you do 85 squared. If A squared plus B squared equals C squared, you have a right triangle. That's it. If it doesn't, then you don't have a right triangle, which we know if C squared is bigger, it's obtuse, and if C squared is smaller, it's acute, but if they're equal, it's a right triangle. Number 26, you're finding the midpoint here. To find the midpoint, add your x's together. -5 and 13 makes 8. Take half of it and you get 4. Add your y's together. -12 and -16 makes -28. Divide by 2. Hello? Hey. Yes. Neely, you need to see Mrs. Deweese in the office.
Okay. Okay, this one, this time.
So what you're doing when you find the midpoint is you're averaging your x's and you're averaging your y's together, finding that middle point, okay? 4, -14. Number 27 asks you to find the distance, okay? The distance formula, I didn't write it down here, but it's x2 minus x1 squared plus y2 minus y1 squared, all of that under your square root symbol, okay? So your x2 value is 2, your x1 value is -18. 2 minus -18 is the same as 2 plus 18, which is 20. y2 and y1, -17 minus 4 is -21. I don't care if it's negative or positive. When you square it, we already answered that with our very first question on the test. When you square an integer, it is always positive. So this is going to give me +400, +441, +841. And if you square root that, you don't even have to simplify it. It says simplify if necessary, but the square root of 841 is exactly 29. So it's a perfect square. Bonus question. The area of a triangle is represented by the formula A equals, under the square root, S times S minus 21 times S minus 17 times S minus 10. So 21, 17, and 10 are the side lengths of our triangle. S is not the perimeter, but half the perimeter. So for anyone that said S was equal to 24 and plugged a 24 in for their S's, you got a point for this problem because you found half of the perimeter. Perimeter is 48, so S is going to be 24 then. If you correctly plugged in 24 for S, 24 minus 21 is 3 there, 24 minus 17 is 7, and 24 minus 10 is 14. Multiply that all together to get 7,056 and square rooted it to get 84. You got 2 points. That's the area of your triangle is 84 square centimeters. But it asked you for the height. So now, knowing what the regular area formula is for a triangle, area equals 1/2 the base times the height, which we do not know. I think some of us forgot the half. Okay. Half of 21 is 10.5. Divide the 10.5 over, and that tells you the height of your triangle is 8 centimeters. Claire,
I could have done that so much easier.
how?
Like, I did that so much more. Like, I could have just done it that way.
Okay, how?
I did it so that I guessed and checked. And
I graded it, and you did exactly using that same square root right here. Now, you guessed and checked. That's not solving.
For the height.
For the height, you get, okay, so you guessed the height.
Well, but then I like proved it by like doing the a squared plus b squared equals c. Like,
Okay,
I proved it and like I did the work, but like it just was, I could have spent a lot less time on it if I had done it
the
different.
problem is that some people were trying to say, well, I can find out what this side is because this makes a right angle here. If I do 17 squared as my c squared, this is my hypotenuse, and 21 squared is my leg. 21 squared is not the leg though. 21 squared gives you the entire base. And so we don't know what just this portion is. If I told you what just that portion is, you would not need to use any other information. You'd be Pythagorean theorem and you're done. But you don't know what that portion is.
I
So-
didn't, I don't know, I didn't use the 21, like basically what I did was like, I guessed that like, said I guessed the height was 8. Then I did like 8 squared plus b squared equals 10 squared, and then found out what that little length of would be, and then made the 21 minus whatever length that would be, and then did the Pythagorean theorem on like the 20, like the, I think it made it
Claire.
was 11.
Claire, I'm going to stop you back in your first sentence when you said, I guessed. We don't want to guess because what if I would have made it 8.3? Would you have guessed 8.3? Probably not. right? So
Eventually, maybe.
Theoretically.
you could guess and check it, and you did, and that's fine, but I still saw that you had used a lot of the
Yes,
work. that you
I'll
needed
be
to work here. AJ, no, just for this triangle. Now, it does work for all triangles if you know what the side lengths of your triangles are. Like, you gotta know what these three numbers is, but S right there, yeah, that formula does work for all triangles. No.
Why would we?
Okay, Caleb, I'm gonna ask you, wait until we're done with our notes, but I will change your score on your test, okay? Because I'm recording right now and I'll make sure I want to record and send this all out as one video. So I need you guys to open up your notes again from your exponents notes, not the exponents packet right now. Save those questions for when we're done. I'll stop recording and then I can go over your questions. But we need to finish up our notes. That's chapter 10, 10.1 to 10.4. We have what, three problems left. All right, while you're getting those out, let's review what we learned so far about exponents. If I ignore the basic exponent stuff that I went over yesterday, this is a new idea here. That if I multiply two powers together that have the same base, I can just add the exponents. If I divide two powers together that have the same base, I can just subtract the exponents. If I'm raising a power to a power, I can just multiply the exponents. And if I'm raising a product in parentheses to a power, then I can distribute the exponent and say that this is 3 to the 5th and 2 to the 5th, which came into play in a couple of our examples. And we have tons of examples that you can look through on what to do with those problems. We left off right here, though, when we were talking about negative exponents. Negative exponents reciprocate your problem. So I guess 0 is the first one up. Anything to the 0 power is 1. Pretty simple, except 0 itself. Can't do 0 to the 0 power, but anything else to the 0 power is 1. So once we get past that, let's just talk about the negative exponents then. Negative exponents reciprocate your fraction. So if you don't have a fraction, think of it as 4 to the negative 2nd power over 1. The negative exponent is going to flip it upside down and make it 1 over positive, or 4 to the positive 2nd power. Okay. If the negative exponent is already on the bottom of a fraction, it's going to flip it right back to the top. Okay. So if it's on the top, it goes to the bottom. If it's on the bottom, it goes to the top. Lots of examples of that as well. Please remember that unless this is in parentheses, just the number directly below the exponent is getting raised to that power. So I would not bump the 8 to the bottom here. This is 8 to the 1st power. Okay. X to the negative 2nd power takes those two x's on the top, x times x, it's going to put that x times x on the bottom. The 8 stays put. Now, if I put parentheses around that, that's an entirely different story, because now the 1's going to be on top and the 8x squared is going to be on bottom. But there was no parentheses here. Okay. If there was parentheses, I would distribute that, make sure both numbers go on top. All right, example G. I could think of this two different ways. The first way I could think about this is saying, let's apply that negative exponent right now. Let's make this 1 over 10 squared to the positive 8. In which case now I apply the power of a power rule. What's 10 squared to the 8th, Harrison?
Oh, 10 to the 16. That's right.
Yep, that's right. Yep. So I could apply the negative exponent property, then the power of a power property, or I could do it in the reverse order. I could just as easily have said 2 times negative 8 is negative 16, and then put the 10 to the 16th on the bottom and still get 1 over 10 to the 16th. I mean, I can do it in any way. It does not matter. But you should get 1 over 10 to the 16th. But 10 to the 16th should be on the bottom of your fraction. This one's tricky. Take 60 seconds and just try this one on your own. Don't talk to anybody. If you already tried it, double check. Try this one on your own. It is tricky. No. Cleanse. Like, get one of those Nuvage things where I stick my nose in there and it like blows the water up my nose and back out.
Weird, I've seen those.
One
Whenever I congest, I want to see that.
I bet you if I was done with that, I could sell that water on eBay for $5 a gallon. Somebody will buy it.
And no one.
Yeah. Mucusy nose water out of my nose. Someone will buy it.
Someone would buy it.
People sell dirty socks on eBay. So I mean,
I think I would. I just realized I'm wearing 2 different socks. That would be a deal.
Max, what'd you get?
The in parentheses, -125, out parentheses. On the next one.
No.
I don't.
Devin, what'd you get?
Positive one.
+1. Who got +1 as their answer?
I almost.
Are these hands up going for +1?
Yeah.
Okay, hands down. Did anyone get anything else? What'd you get?
Negative one.
Negative. Who got -1?
I got something else. I got.
Caitlin's saying it with
Wait, no, I didn't
you.
get negative one.
She got -1.
No, I didn't get -1. I didn't get -1.
What'd you get?
I got 1/-5. I threw it.
Okay.
That's what I thought.
Which you weren't supposed to evaluate it anyways. You were supposed to write your answer as a power, unless it was to the 0 power, which is why most of you said you got 1 then, right? Okay, let's see what you get.
Oh, you're supposed to write.
No, I'm not saying you're
One's
wrong.
-1.
All right. So here's what's important here. That negative. That negative is really important. Because anything to the 0 power is 1. We know that. However, that negative is not in parentheses. Now, I know what you're thinking. Yeah, it is. You forgot to look. It is in parentheses. No, it's not. The parentheses that you see right here are for this exponent, not for that one. So it really needed to have 2 sets of parentheses around it if the negative was going to be also raised to the 0 power. So because those parentheses, that double set, that inside set of parentheses was not there, this is what we have then. We have 5 being raised to the 0 power, which is 1. The negative was not touched by the exponent. This 0 right here cannot see the negative sign because it doesn't have the magnifying glass, those parentheses to look into. It's already in the magnifying glass. So it's only going to do 5 to the 0 power. It's not going to do -5 to the 0 power because they didn't use a double set of parentheses. So then inside the parentheses, I get 1. The -3 is going to make this 1/-1 to the 3rd. -1 times -1 times -1 is -1. So this is equal to 1/-1. And what's 1 divided by -1? -1 should have been our answer if you had. Sure you did.
Should've said that.
Nobody raised their hand. Even the kid that said -1 said, oh, never mind.
I didn't have it
You
written
also
down.
could just do
Uh-huh.
negative, you could do,
Wait.
you do the whole thing in parentheses, you could do like -5 to the 0 power. and then
1
do
over
the 0 for the
If
whole
you put it the
thing.
-5 itself in the parentheses.
Yeah, but if you just did the 0 for the whole thing, you could say -3. I don't know how this works, but you could also say 3 negative.
Okay, stop while you're
This is
at it.
divided. I only got -1.
Last problem. A drop of water leaks from a faucet every second. How many liters of water leak from the faucet in 1 hour? So this is how much a drop of water is. It's 50 to the -2 of a liter. One of those drops goes every single second. So take 50 to the -2 power, and it's going to drop every single second. So how many seconds are there in a minute?
60.
And how many minutes are there in an hour?
60.
Okay, so that's 60 times 60, isn't it?
3,600.
Yeah.
3,600?
Yeah.
Okay, now, can I multiply the 60 and 50 together and then add my exponents? Why not?
Yes, you can.
Because they don't.
Yeah.
Oh, wait, no, you
Yeah.
can't. They're not the same
Yes,
base.
they do not have the same base. So I cannot just, because I wrote, instead of writing 3,600, I wrote 60 squared just to make it seem like I could do that. I cannot. They have to have the same base for that power times a power property to work. You can't add the exponents unless they're the same base. So I'm going to call this 3,600. I'm going to call this 1 over 50 squared. By the way, what's 50 times 50?
2,500.
Okay, so I got 3,600 times 1 over 2,500. That, by the way, is the same as just putting the 3,600 on top and the 2,500 on bottom. And that's going to cancel. We got some stuff that can cancel here. We can divide by 100 and cancel out those zeros. Since 36 and 25 are perfect squares, can we cancel them out?
Yes.
No,
Yeah.
No.
Yeah, I was about to
it doesn't
say.
work that way.
Square root.
They have to have a common factor. I know 6 goes into 36. Does 6 go into 25?
No.
I know 5 goes into 25. Does 5 go into 36? So my answer then is 36 over 25, or maybe a better answer would be 1, thank you, 11 25s, 11 25ths.
Sorry.
Okay, and that's, what is the answer here? How many liters? That would be the number of liters.
Real quick.
That's how many liters of water you're wasting if you have a leaky faucet that drips 1 drop every second, every hour.
I have a different answer. But I got -1 on the last one, but like,
I just did this, right, and then I got, put on bottom.
Yeah, but that 0 exponent, it only sees the 5. That 0 exponent there only sees the 5.
okay, so that makes it 1.
So 1
And then you put the
over-
negative in front of it,
Yeah.
which is 1 over
But that's the
negative.
same answer.
Yeah, I know, I'm just saying, I got it a different way.
All right, we are done with the notes. So I'm gonna be done with the video. You guys are working on your packet. It is due tomorrow when class starts. I can help you with any questions you have. If you want to get with a partner and double check things, especially the ones that you can't check on big ideas, the A, the B, the C, D, E, F, then you can check those as well. We will go over them when class starts tomorrow before your murder mystery. Okay? Get started.
I have no clue how to send it.
Yes, you can use the restroom right now. It's a good time to do it.
So I got this.
Hang on, I'm gonna stop the video.
Hi, video. Boy.